Hi minions, we will try and solve this problem. If you need extra time to read it, you can pause the video. Let us bring in the whiteboard and the full solution. I will walk you through each step of the solution. First, we will explain the concepts used to solve the problem. The concepts are momentum, momentum transfer, and impulse. The later two combines into the impulse-momentum theorem. Before we attempt working with our toolbox of equations, we should visualize the problem through a sketch. With the information given, we have the baseball moving to the right, with an initial state of motion, say state 1, then engaging in an interaction where momentum is transferred to the baseball, and finally motion in a final state, say state 2. Our solving methodology will be: find the initial and final momentum of the baseball. This will allow us to calculate the change in momentum. The next step is to connect the fact that change in momentum is momentum transfer or impulse. From the definition of impulse, we can solve for the net force applied to the baseball. Now let us proceed through the calculation steps. Since we are working with vectors and will need to subtract them analytically, we will need to decompose the vectors into components and must establish a reference frame for that purpose. The location of the reference frame is not essential. Only the coordinate directions are of importance. I choose a standard Cartesian coordinate system as shown at the top. The initial momentum only has a positive x component, as the baseball is traveling along the positive x direction. Inserting our numbers into the equation for momentum, we can write the initial momentum as a column vector. Feel free to pause the video or scroll back if you need. The final momentum requires a little more work. Here, we are presented with a vector that has both x and y components. It is a good practice to draw the vector and then show the components making up the vector. I have done this in the top right corner of the whiteboard. Using trigonometry and observe the directions, we find the two components. Inserting our given values, we find the final momentum of the baseball. To find the change in momentum, we simply subtract the initial momentum from the final. Next step is to implement the definition of impulse or momentum transfer. It is defined as the force acting through an elapsed time. We can solve for the force and insert the numbers calculated above and the given time. Pay attention to the fact that the time is given in milliseconds. The problem asks for the x and y components of the force explicitly. Taking into account significant figure, notice the angle only has one, and we can report the final answer.